Hello people, welcome to another very lazy video. Well, this morning, it is almost 1 a.m. I did something kind of unexpected today, or rather yesterday, but I'm still gonna say today. I realized something. Now in my past couple of videos I've been talking about a lot of Noctalia, Kinetic WE, Hyperland, etc. The reason I like those a lot is because I could customize absolutely everything I would ever want. And if you're wondering why I'm quiet, it's because my whole family's asleep. But anyways, I could do whatever I want. And that's what got me off of GNOME in the first place, is because on GNOME, without extensions, it's kind of not restrictive, but the customization that Linux offers you, that's not the priority of GNOME, right? Which is why I tried to transition into something else. But I realized something in the past few weeks. Ever since I've gotten onto that Hyperland train, doing YouTube, thinking I'm being more productive, I've been not having fun on my computer. And what I mean by that is, this computer, the primary goal of why this computer has been built, was to play video games, okay? It was to play video games, and I have not been doing that, which is crazy, because there was once a time where video games were my favorite thing. And if you're wondering why I'm quiet, it's because my whole family's asleep. But anyway.
I have something I'm a bit ashamed to admit. I'm a pretty big fan of Meta, not of things like Facebook, like, no, gross, not my thing at all. But when it comes to their actual software contributions and things they do for the ecosystem, I found them to be pretty solid, if not great. Projects like React and React Native were essential to the growth of the web and to an extent mobile as well, and are genuinely incredible things that they've put out there for free for people to use however they want. Their contributions to the AR and VR ecosystem were all things that I enjoyed heavily at the time because I'm a big VR nerd. And when they started getting into AI, they did that similarly well with their focus on open weight models with the Llama line. To this day, Llama is still used almost like a generic term for open weight models, and it's crazy how far the Llama models went, but it's even crazier how far the entire industry has moved ahead of Meta. They've been trying to correct course for a while with this hidden, quietly worked on line of models called Muse, and historically they have not been accessible beyond their little web interface to try it out. But apparently they've been trying to make it ready for code, not just the model, but the tools around it as well. And now they're finally ready to release. Zuckerberg just announced on Twitter, by the way, that Muse code is out in beta today. This is their clone of Claude Code, and it's powered by Muse Spark 1.2, which is their new coding-focused model. It's been a while since I've seen a lab publish benchmark numbers where they're not in first place in anything, but that doesn't mean it's a bad model. As you guys probably saw in my video about Grok 4.5, there is still a lot of value in well-priced, fast, useful models. And with Meta's focus on using every model for everything lately and collecting all the data they get as a result, it's actually going to be pretty interesting to see how well this performs. So I'm going to go through this with y'all together. I'm going to try it live. I'm going to read through what they have to say. I'm going to see what others are doing with it, get a feel for the price and the weird quirks as well. And I just had to sign into my terminal with Facebook, so I'm feeling a little gross. This is going to be a journey, and I hope you enjoy it with me. But first, a quick break for today's sponsor. There's a lot of code review bots around nowadays, and they're pretty good at reading the code. But I've noticed that running Claude Code and Codex on my machine tends to be better, simply because the models can actually run things and verify the changes. Wouldn't it be great if those review bots had the ability to actually verify changes on a real computer? Greptile thought so, and that's why they introduced T-Rex. It's a new sandbox that can actually run your code and verify the changes rather than just reading the syntax and hoping it's good. If you've ever added an element to your UI and had it overlap something that was obvious when you ran it that the code review bots missed, that's what this is for, because the models can actually click through and test things, and it can even respond with screenshots of the things it finds along the way. Their website lists a bunch of real-world open source projects that have had bugs prevented through T-Rex. Even companies like WorkOS are finding real bugs. For example, this code that seems like a totally safe filter but has a really rough edge case that you'll only find when you run it on real data. If you've shipped a bug in the last 3 months, you owe it to your team to check out soydev.link/greptile. So let's start with what Zuckerberg had to say about their most recent release. Releasing Muse code in beta today. It's a terminal coding agent that takes on complex software engineering tasks across large repos, planning changes, writing code, validating the results. It's powered by Muse Spark 1.2, which is a coding-focused model update. This is going to be an interesting one because a lot of the other legacy companies like, Microsoft and Google don't necessarily have the best stack internally, whereas Facebook has done some incredible things with their internal tech. They didn't use Git because it was too slow for the scale they were moving at, so they built their own custom everything on top of Mercurial, and it's really powerful to the point where people have been trying to copy their workflows with things like stacked PRs and stacked diffs. I know a lot of people who used to work at Meta and left and just missed all of that tooling that made it so much easier to work in these gigantic projects that are Meta scale. Other companies like Google also have gigantic monorepos, but they are less focused on fixing them. In fact, they've went as far as laying off the teams that built the tooling to make them usable. Meta's always done the opposite, where they'll rewrite a language if they have to, like they rewrote PHP in Hack, in order to try and make their code bases work better. Since Meta's code bases are so huge, it's often easier to rewrite the language that's underneath them than it is to rewrite the code base itself on a better language. And that type of thinking is, at least it was, unique to Meta for a long time. And I think it kind of positions them well to dive into this world of using models and tools to work with your code bases at that scale. And that's why they've been using models like Fable and Opus so heavily recently. So it's interesting to see what they're cooking here. They shared some benches here, and the first notable thing is that they're not putting Fable or Sol in these lists. They're only putting Opus and 5.6 Terra in, which is a choice. In Terminal Bench 2.1, they slightly beat out Terra and are slightly behind Opus 5. There's also a big jump from MuseSpark 1.1 to 1.2. 1.1 was barely available to the public. 1.2 is now actually out, and the pricing's really interesting, which we'll show in a little bit. Deep SWE, which is one of the benchmarks I prefer, it did pretty well here, getting a slightly higher score than Grok 4.5, which is nuts because I actually found Grok 4.5 to be a very pleasant to use model, but it's still lagging behind Terra and Opus, which means it's far behind models like Sol and Fable. And then Meta's internal coding bench, it came in second place in, with MuseSpark being much closer in third. And if this model is as far off as other benches showed, I think their internal bench might not be the best. They also, in their internal bench, have Terra and Gemini 3.6 Flash, suspiciously close. So we shall see as we go. Oh God, they're already getting community noted. Community note, Meta is still dead last in AI with this release. Okay, maybe not, Apple is, but they're behind just as much as Google Gemini is. That's not a thing you need to put in a community note, nerds. Anyways, according to Zuck, Muse Code runs specialized background agents that stay active your whole session, so they build up context over time instead of starting from scratch on every task. Interesting. When a job is big enough, it fans out the separate sub-agents working in parallel in isolated work trees. Your working copy is never touched. In testing, we had it build 6 features for a game simultaneously with no collisions. Very interesting. Again, big code-based stuff. We pointed MuseSpark 1.2 at a kernel optimization task and let it run. 1,000 tool calls over 24 hours on NVIDIA Hopper. It kept finding substantial improvements well beyond the initial exploration phase. This is also kind of funny to me because Meta rented a bunch of TPUs from Google. They're one of the few companies to actually buy and rack hardware from Google. And then Google went and rented a bunch of GPUs from NVIDIA, all from XAI and SpaceX. So Google is reselling their shitty chips to Meta so they can use the money to go buy better chips from NVIDIA through XAI. And now apparently Zuckerberg is still stuck on NVIDIA. Auditable by design, every model call, tool run, and edit has a local event log before it executes. If it crashes mid-task, it picks up exactly where it left off from that log. No lost work and no reprompting. Pricing. It's easy and low cost to get started. Install Muse Code with one line and you can start on our contributor tier. Contributor tier is an interesting piece we'll talk about in a second. MuseSpark 1.2 is our next step as we push towards Frontier with larger, more capable models on the way. Install it, use it, and tell us what you think. Well, the first thing I think is that when you Google search MuseSpark, you get all of these old articles about 1.1, this old developer page. Okay, this one has 1.2 on it now, but it was actually kind of hard and annoying to find this initially. Here's the part I was looking for, though. The price. $1.25 per mil in, 15 cents for cashed 1 mil in, and $4.25 per mil out. Not great pricing until you realize I was hiding something from you, the contributor price tier. This tier is 10 cents per mil in and 20 cents per mil out, with 0.2 cents per cached input token. That is a 10 to 20x price gap. They're effectively giving out the contributor version for free because they need training data so goddamn badly. Meta's released MuseSpark 1.2. It's their third release in 4 months, and it scores a 54 on the Intelligence Index, significantly improving agentic knowledge work capabilities over prior releases, putting Meta next to SpaceXAI in a tie for third place amongst US labs. Crazy they have to specify this now because the Chinese labs have caught up so much, especially with K3. MuseSpark 1.2 lands at a 54, up 3 points from 1.1, and 11 points from MuseSpark 1.0, which came out in April. That's a pretty big jump. Like if we're just looking at the trajectory of what Meta right here, that's a lot of improvement in not a whole lot of time. It's effectively tied with GPT-5.5 and Grok 4.5, narrowly behind current frontier models like Opus 5, Fable 5, and 5.6 Sol, as well as Kimi K3. It's among the most cost-efficient models at its intelligence level. It's 40 cents per intelligence index task at Meta's unchanged $1.25 and $4.25 per million token pricing. They don't mention, I was right when I was reading that earlier, they are not measuring the prices based on the contributor tier. They are measuring them based on the normal pricing that they would charge actually. So if we go back to the pricing chart here, it's about a 10 to 20x difference in price, which means MuseSpark 1.2 on the contributor tier is actually the cheapest model currently here because it would be 2 to 3 cents per task, which is comparable to V4 Flash as well as 5.6 Luna. Very interesting. This model, especially if you're down to like let Meta have your data, could be a really good value for the short term. Omniscience abstention rates have increased. The model's score rose from an 18 to a 22, and the hallucination rate fell 10 points. The attempt rates dropped from 82 to 67. This bench is measuring how likely is the model to lie when it doesn't know something, and it's much less likely now. Even though, from my experience, that is not the case. Scientific reasoning results remain largely unchanged. Does much better at GDP val, but I still don't love that bench. Good analysis. We can work with that. Muse is trained heavily on data from people using models like Anthropic models internally and all of the work they do. I've heard numbers as high as 50% of staff at Meta have been moved over to some type of data labeling or like management tasks in order to help them train smarter models. And one of the results here is this wonderful tweet from Luke. Muse Spark is trained on the screen recordings of Meta employees, which makes it best in class at applying for jobs at Anthropic. Absolute banger. I want to go through other numbers that matter before showing off the code that I can write with Muse. I already have it working in the background and it's surprisingly fast. We'll talk about that in a sec. But first, I want to look at the numbers from artificial analysis. As you can see here, Muse Spark 1.2 falls right between Kimi K3 and Grok 4.5. I will say it's a little bit embarrassing to release a closed weight model as a lab that has billions of dollars like Meta does, and have it be behind an open weight model that came out much before it. That is a little embarrassing, but also if it's really fast and cheap and reliable, these numbers don't mean everything. Because I can tell you confidently that Opus 5, despite being at the front of this list and tricking me into thinking it was a great model, ended up all being Copus because I hate using Opus 5 now. Once I started merging the code it wrote, I realized how bad it was because I had to have Fable and 5.6 Sol come in and clean up the mess. Not great. But again, Kimi K3 actually felt quite usable, as did Grok 4.5, but Opus at the front doesn't feel usable for real code work at all. But what I really want to see is output tokens. How did they do here? Interesting. Okay. So Muse Spark's runs did about 30K tokens per task, compared to about 36K for Fable 5, and compared to about 17K for 5.6 Sol. So it's not quite as inefficient as Anthropic models, but it is far from the efficiency that we see from models like the GPT line or Grok 4.5. Very interesting. Definitely puts it in a weird, different spot. Like this model isn't just another open weight model tuned or something. Like this really is a new model, and it should feel quite different, especially when you look at the speed that this model has too. I don't think they have recent speed numbers yet on artificial analysis, but they do have them on OpenRouter. OpenRouter is an easy way to use pretty much every model, and they track the throughput and speeds that users are actually seeing when they use the models through OpenRouter. And they're seeing an average of 191 tokens per second, which is absolutely nuts. For reference, 5.6 Sol is only at about 30 tokens per second. So that is a gigantic improvement, like 5x plus. Absolute best case with Sol is 134 TPS, but realistically speaking, the P50s in the 40s to 50s on OpenAI's official infra and in the 50s for Azure at best. To compare, Muse Spark gets 316 TPS at its best and 162 at its P50. That is pretty nuts, and I feel the result coding with it already. Man, that Cerebrus deployment of 5.6 Sol can't come fast enough. It was supposed to already be out, so I'm not sure what happened there. No one's given me any info, sadly. But then we get to cost, and Muse Spark is performing absurdly well here at 40 cents per task on average through the Artificial Analysis Intelligence Index. That's still more expensive than V4 Flash is, as well as 5.6 Luna on Max, but it's a lot cheaper than other things. Even Mistral Medium is more expensive, and Kimi K3 is more than twice the cost for similar work. And I'm assuming this is the normal cost too, not that contributor tier, which is effectively free. I think it's about time we fire off some prompts. I just opened Muse code inside of the T3 code base. It's defaulting to 1.2 contributor on high. And since T3 code is fully open source, I don't mind if they get my data. They probably have it anyways. I asked it to give me an overview of the architecture of the code base, and it had this under 30 seconds. Not bad. Let's see where this goes if I ask it for something a little harder, where I asked it to investigate more. I asked it if it can find anything suspicious about the event sourcing model, things cause weird behaviors on different platforms, unnecessary bandwidth usage and lag, etc. Let's see what it does for that. Another interesting thing I noticed when I set this up is that it pulled all of my skills and personal rules from Claude code. Normally, things don't use the .claude directory because it's Claude's. They use the shared .agents standard and agentmd, stuff like that. They seem to be really focused on Claude. And from everything I know about how Meta's been working lately, they're definitely an Anthropic house. They use a lot of Opus and a lot of Fable there. Yeah, 174 TPS. Okay. Now we're talking. For comparison, Grok 4.5, which is still quite fast, is at 50 to 52 TPS. And a model like 5.6 Sol is 30 to 50. It's crazy that Azure is performing that much better than OpenAI's official servers are right now, but yeah, you're welcome. I had to fight hard to get Azure to move. It had some interesting findings here. I'm going to tell it to summarize them. Summarize your findings in an easy to digest HTML file. Let's see if it's able to find my HTML plan skill and actually take all of this work and synthesize it. Look at that. Already found the skill. Now it is thinking. Hopefully it will synthesize this properly and then put things up. It's interesting to state how much data the skill is. There's definitely some slop in here. Things like the way that the full path for files is included in the UI and stuff. Like this CLI is a bit slop. Here is the HTML it made for me to summarize the findings that it had. Pure decider plus single serialized worker is correct. Cost surface is at the wire. Full snapshots on subscribe. Unbounded payloads in a global sequence that couples every thread. Cool. So here's what we'll do for a comparison. I'm going to do a Claude run with Fable. We're going to paste this. I have a plan here. You know what? I want to try DeepSeek 4 model, DeepSeek v4 Flash. Let's copy over the same prompt then. God, that is fast as fuck too. For reference, Muse 1.2 got me this feedback and even had an HTML page generated all in well under a minute. I've just been trying to get similar feedback from Fable, and we're over 4 minutes in and still don't have any useful anything here. I also have DeepSeek Flash running in the background as well, just as a comparison, because the new Flash release was really solid too, just to get a comparison across things here. RG wasn't finding them because I used -g quote star.ts, which doesn't work on macOS with ripgrep. This is the DeepSeek one running, by the way. God, these are both so slow and not getting me useful feedback so far in comparison. It's been very interesting. My plan is I'm going to take the findings that Muse had and throw them at these other two models after and say, how do these compare? So my favorite ways to get a feel for what models' strengths and weaknesses are is to have them all do the same task, have them write up the results, and then have them compare each other's results. DeepSeek Flash just finished its analysis. I'll ask it, write up your findings in HTML. See if it can figure out my HTML skill. Use my HTML skill. You can read it from my .agents or .claude. It doesn't have skills built in by default, if I recall. Oh, it did. It found it. Nice. After waiting way too long for both Fable and DeepSeek to do a similar investigation, I asked them both to review their findings and compare it to what was found with Muse 1.2. And here we see the way that Fable categorizes the differences. And remember, Fable, when doing a similar task with Opus, thought that Opus had a much better investigation overall. It seems like that is not the case with the Muse investigations. There are a few places where it said that Muse did better. For example, the coverage breadth, it thinks Muse went a little further on. But for the most part, it thinks it did worse, and that Fable's plan was much more accurate and overall properly found root causes. Meanwhile, DeepSeek seems to think that the Muse plan was meaningfully better. Very interesting. Yeah, it's a solid model for the price, but I don't know if I would trust it for really heavy end-to-end work yet, but we'll test it a little more. I had to try one of my favorite tasks where I take my crappy fish game and have it remake it both in 2D and in 3D. And the most impressive thing is how quickly it did it. It made the 2D version in about 2.5 minutes and the 3D version in under 5. For reference, Opus 5 took over an hour for both of these. It doesn't move properly. Like, I can't turn. Kind of nuts that it made this whole thing from scratch in 4 minutes, though. Like, that part is impressive. It's just that the rest is broken. Mouse look does not work. And it made a 2D version of Fish Slop as well in 2 minutes and 39 seconds. For reference, when I put these same prompts to remake this game into other models like Opus, it took multiple hours to do. And this made it in under 5 minutes for both the 2D and 3D versions. Is it perfect? No, far from it. But it does have a couple niceties. Like it made solid animations using the sprites that it had access to from the other project. It did shadows and like contrast well. Like it has a weird type of taste that I haven't seen models have. It's obviously still jank as shit in a lot of ways, but like the little shadows are nice. The way things are moving is nice. It feels fluid. Like this model feels different. It doesn't feel like it's just distilled on other popular things. It does have a vibe to the results. And I am definitely curious what's going to happen when they make bigger and smarter versions. It allegedly just fixed the 3D mouse broken stuff in a few seconds. And it does appear that it has. I can now look around as expected. The fish are all swimming backwards, though. That's hilarious. Fish are swimming backwards. I can't look up or down, only left and right. Can you use computer use to test it yourself? Oh, I found my codex computer use skill. Oh no, that is not the solution. As if it can do it itself without codex. Does it have vision? Oh shit, it does. That's huge. Okay, now the up and down movement of the mouse tilts this. That is broken as shit. And the fish are still moving backwards. It promised me it fixed that. Oh, wait, no, it didn't. Yes, please fix and rebuild. Okay. Nope. Fish move the right way now, but I still can't look up and down. Spaces both feed and go up. Yeah, there's a lot of little things it got wrong here. Like it doesn't understand that things can collide with each other, which is interesting. So one of the things they said the model was good at was like breaking things up and letting lots of stuff work at the same time. But it's getting work done, and it's doing it alarmingly fast. Like that's one of the nicest things here is using it to like touch something up seems to be a useful method. Dara just got me one of my favorite things to look at when new models drop, the comparison of how it handles design on his whichai.dev site. Very nice for like looking at the designs that different models do and comparing them. And I'm already seeing some interesting things here. Like I love how it uses the scroll areas where this like graphic on the side scrolls with you until you hit a certain point. The sections are tasteful too. I don't hate this. I'm tired of the pills on everything. It feels a little templatey, but not bad at all. And this little tilted reminder recall thing here is nice too. This is all without the design skill as well. If we switch to the second one, we end up with one of the cringy code style ones. It's laid out well. Like its page layouts are solid so far, but I don't love the design and the graph it made there. It really likes doing these tilted things. It has one here as well. I really like this one. Of them so far, this design looks decent, and I like the way it's using the like squircle here. I don't like that it switches from squircle to rounded there. This isn't bad though. This again is reminiscent of Gemini to an extent. Way too much text, but otherwise not bad. Oh, these brutalist ones are getting tiring. I say after making lawn video, which is absolutely of this style, but yeah, it's not bad. Like nothing jumps out as like, that is horrible. I don't love having the bar here when it's already a very brutalist, like line heavy style. And now the classic like Tailwind template homepage. Oh, it does these little floaties well. I like how it uses those. Other models get that stuff really wrong, and I've fought it a ton on things like the T3 code marketing site. That's like what's interesting about it. This model just has a bit of a different flavor. You know what? Let's give it something harder. Does it have work tree support first off? It does. Huge. That means I could play around with less risk a bit here. Can I YOLO mode from here? Nice. Oh, that's a bit annoying because I had that in a work tree. -- work tree -- YOLO. Now we're in a safe work tree where I can ask it to do stupid things. Like, let's try their voice, actually. I would like to implement Muse as a provider inside of T3 code. I'm not sure what Muse code supports in terms of integration methods. I haven't played with it enough or looked into the SDK. I don't even know if it's open source. What I really want is to integrate it through a layer like ACP, similar to how we have integrated other providers in the past. But if we need something more custom, I am down. I would like you to start by investigating everything you need here, both how we can implement within T3 code, but also what is offered by Muse itself. You'll have to do some digging to find source code where available, docs, SDKs, and whatnot. Might be a bit hard to find because this is all still so new. Use a lot of subagents to break up the work as you go. I actually liked that voice to text. It showed things as I spoke, which a lot of other solutions don't. They just show it when you're done. So let's send that over and see how it goes. That's the first good terminal voice to text I've seen in any of these CLIs, if I'm being real. Look at that. It's already spawning subagents, and we can look at them almost the exact same way we can in Claude. I know I clickbaited a bit saying this is a Claude code clone, but like, this is such a Claude code clone. It's cool that it spun up all of these intelligently. Like it's clear they are trying to make this model good at this type of like broken up, heavy subagent breakup work. I just got hit with a rate limit. Are you kidding? I put in a credit card and everything. Are these subagents getting hit with them too? They are. Great. Why would you make a subagent flow like this if your APIs can't even handle it, Meta?